Okay, we're gonna do section 2 of our combining forces video now, and let me get our document in here. For this section, you're gonna be using page 89, and here it is. Let's peruse it real quick. It looks like 2 paragraphs of reading. It's got a couple of diagrams or figures on it with some captions. So take a couple of minutes and look at this guy, read through it, see if you can make sense of it, and then I'm gonna go ahead and try to explain some of the ideas from this page right here. So from our section, the first thing that they ask is, what is a non-contact force? So that's going to be found in this first paragraph. It says, well, let's just look at it right here. It's something to do with this little skydiver, and he's being pulled downward by a non-contact gravitational force. Okay, so a non-contact force is a force exerted on an object even though they aren't touching each other. So obviously gravity can't touch you, it just affects you with its force. Another non-contact force example would be a magnet and a piece of metal, or a magnet and another magnet. While they're not touching each other, they are affecting each other from a distance. So that's an example of a non-contact force. The big ones that are relevant to our conversation are the gravitational force. That's the force that all physical objects exert on each other. The electric force, it has to do with electricity. If you keep going in physics and in mathematics, you'll learn more about this little guy. And then the magnetic force, which is the one that fascinates so many people when they're kids. Why do magnets work? How are they related to electricity? What's going on there? If you're excited or interested about those things, do a little bit of reading and see what you can figure out about it. Okay? It says, give an example of a non-contact force. Well, I mean, those are the main non-contact forces. So, yeah, just insert one of those examples in there. Now, when we talk about force, we talk about force as a vector. Right there. Okay? This is a little reading of 1 paragraph or 2 paragraphs of force as a vector. Peruse it. Take a look at it. See if you can make a little sense about it. It's kind of a little bit complicated. It goes on to say that force is a vector, and we know that vectors have a size, that's the length of the vector arrow, and a direction. That's which way the pointy end is facing. So a force, which is a push or pull, can have a direction that it's pushing or pulling in. That's which way the vector arrow would point. And then it would have a length. And the length would be the strength or the size, or better yet, the magnitude of how much force is being applied to the object represented by the vector arrow. So that's kind of what a force vector is. Take a look at this paragraph. Hopefully it'll make you a little bit more clear. The units of force are right here. They're called newtons in honor of the person who described this type of physical interaction between people, Sir Isaac Newton, many hundreds of years ago now. The newton is the force needed to lift about half a stick of butter or a fast food burger. They said is about 1 newton's worth of force. So if you've ever lifted up a burger and put it into your mouth, the amount of force that it takes to lift that burger up is approximately equal to 1 newton. It says here that lifting a 2-liter bottle of water requires about 20 newtons of force. And let's look at figure 3. So we're going to insert this guy in there, and let's find out what's going on in here. Figure 3, this person's foot, it's not a very good kick because it looks like they didn't get underneath the ball very well. You know, like they should have probably had their foot down here a little bit more and more hit it in the bottom. But, you know, that's going to do a little bit of work there. They're exerting 200 newtons worth of force onto the ball, so yeah, it's alright. And then the force vector is that long. I guess this length represents 200 newtons, and the force direction is in that direction there. You're going to insert your own photo of a force being exerted on an object. So yeah, use your iPad. Take a picture of you and a buddy doing some action and then drawing the force arrows. estimate how much newtons you think it would be in there, and yeah, good luck with that. It should be fun.